Yes, Rohit. Any other difference except these four differences between TCP and UDP? Okay, actually, yes.
Header size, sir.
Header size.
Header size.
8 bytes, and whereas in like in TCP 20 bytes and UDP 8 bytes.
8 byte, very good. So these are the basic difference between TCP and UDP, definitely. And what is the use of network layer in OSI model?
It provides the logical address.
Logical address, or you can say IP addresses. And what about the data link layer? Second layer of OSI model?
It provides your physical address so that it hop to hop delivery of the hop to hop movement of your like a frame is possible.
Yes, we cannot say it provide the physical address directly, because suppose if we have two routers and both are directly connected with serial link. So on serial link there is no MAC address. So actually what we can say to data link layer, that data link layer tell us how physical media can be accessed. Right? On Ethernet it provide the MAC address, physical address.
So Ethernet comes at the sir your data link layer.
Yes.
Ethernet frame, है ना?
Yes, Ethernet works at layer 2. Ethernet is a technology. If we are using the Ethernet link, Ethernet media to connect devices, that time at layer 2 means data link layer will add source MAC and destination MAC, means physical address. That time it provide physical address. But on the serial link you will see the layer 2 header will be HDLC header. There is no MAC address on serial link, right? So simply we can say data link layer define how physical media can be accessed, and after that the physical layer. So on physical layer actually devices will transmit the information, actual
Uh,
information.
can we also say that the movement of frame from one hop to the next hop?
Yeah, also you can say that also. Okay, so these are the overview of OSI model. Today we are going to understand transport layer in details. As you know, at transport layer we have two types of protocol, TCP and UDP. We are going to discuss each in detail. Okay, first let me share my screen. Guys, there are two types of protocol. One is routed protocol and one is routing protocol. By the way, we will discuss it later. But anyone have any knowledge about routed protocol and routing protocol?
Routing protocol runs on your router, which is responsible for the communication between the routers. Uh,
Yeah,
uh,
routing
or,
protocol, yes, is uh,
and
is help to collect indirectly connected network information to router. Routing
and
protocol are helping to collect the information about indirectly connected network. What about routed protocol?
these are the protocols which are responsible for the delivery of your data from one place to the one source to destination,
Yes,
like your IP internet protocol.
like ARPA, Internet, TCP, UDP. These are routed protocol. Even if we will talk about the TCP, UDP, both are routed protocol. So actually routed protocols are helping for data encapsulation. You know what is the meaning of encapsulation, guys?
When you add the headers, like when you send the data, you add the information of every header, each and every header. That's called the encapsulation.
Headers. So what is header?
Header contain the information like your source IP address, destination IP address, like your physical address, and yeah, even
Header
so these kind
means
of a
extra
data.
information. Extra information added with the actual data to make the data transmission successful. Yes or no? Header is nothing but the extra information, like putting
Yes, sir.
envelope with your letter. Your letter is your actual information and you are putting one envelope there. On the envelope you are providing the source address and destination address, so that your actual information can be what do we say, transmission successfully to the correct destination. Like that, we have header. Header is nothing but the extra information. Okay. And routed protocol adds header, right? So as you know, at transport layer, we have two protocol, TCP and UDP. How transport layer will came to know that when I need to use TCP and when I need to use UDP? That is predefined. Yes or no? With software. That is predefined with software. So let's say I am using one protocol at application layer, and you tell me which services will use that transport layer. Let's say protocol is HTTP. Tell me this protocol will use which services at transport layer? TCP or UDP? TCP or UDP?
TCP.
TCP. If I will talk about the telnet. So telnet
TCP.
uses which service?
TCP.
UDP.
TCP.
TCP?
Yes.
I'm not work with UDP.
Okay, DNS.
UDP.
TCP and UDP both, sir.
Okay, by the way, it using both, but generally it using UDP. After that, okay, let me add him. If I will talk about the FTP protocol, so this protocol uses TCP or UDP?
TCP.
TCP. If I will talk about the DHCP,
UDP.
very good. UDP. If I will talk about the SSH,
TCP.
TCP. If I will talk about the which protocol, let's say POP3,
TCP.
TCP.
Yes, sir.
Okay, done. What is the port number of HTTP? And one more protocol that is very important, that is HTTPS. HTTPS also uses
TCP.
TCP, right? What is the port number of HTTPS?
80.
80. What is the port number of Telnet?
23.
3.
What is the port number of DNS?
53.
What is the port number of FTP?
21.
2021.
20 and 21. What is the port number of DHCP?
67, 68.
67 and 68. Very good. What is the port number of SSH?
22.
What is the port number of POP3?
1110.
What is the port
110.
number of HTTPS?
443.
443. So guys, these protocols should be very clear to everyone. Port number and the services at application layer. Done. $443. Ramesh. Okay. Now we had discussed the routed protocol, routing protocol. Okay. These TCP and UDP are routed protocol. It should be very clear with everyone. These two protocol are routed protocol because these protocols help actual data to transmit to the right destination, to the exact destination. And transport layer is responsible for service to service communication. Who is joining again and again? Header are extra information. Headers are extra information added with the actual data to make the data transmission successful. Now I am going to discuss the transport header. So TCP header. In TCP header, we have some field. First is source and port number also. What is port number? Who will explain port number? We had discussed port number as well in last class.
Port number services.
Port number is, your voice is breaking, brother. Can you speak again?
Sir, it is used to distinguish between the services.
Yes. And how long value it is?
65,535.
Yes. Range will be?
Range 0 to 1023 is your well-known ports.
Okay.
From 1024 to 49151 is your private ports.
Okay.
And 49152 to 65535 is your dynamic ports, which is used by your operating system.
Very good. Sequence number. Inside the TCP header, there will be source port, destination port, sequence number. After that, acknowledgement number. Acknowledgement number. After that, there will be information about the header length. Header length. There will be information about the flag. So can anyone tell me how many bits we have for flag in TCP header? In old TCP header, there are 6 bits reserved flag and 6 bits are for flag, used flag. 6 are reserved. For the new TCP header, 3 bits are reserved. And we have flag, that is 9 bits. Okay. Flags, and we have windowing information like window size. Windowing. Then just I am going to tell you size as well, size of each field, and then we will discuss each field one by one. After that, there will be information about the checksum. Checksum, there is one urgent field, and we have option and payload. This is your TCP header. So all the services all the protocols which use TCP are going to use these all information at transport layer. Actually, transport layer is going to add these all information with actual data at transport layer. If the services is using TCP, and here we have payload. Guys, size of source port number is 16 bits. 16 bits. Destination port is also 16 bits. Sequence number is 32 bits. So you can calculate the range of sequence number as well. Acknowledgement number also 32 bits. Header length size. Yes, can anyone tell me the size of header length in TCP header? 4 bits. Reserve. In new TCP header, this is 3 bits information. In old TCP header, this is 6 bits information. I will show you practically also that in new TCP header only 3 bits are reserved. So here flag is total 9 bits. And windowing 16 bits. Okay, checksum is 16 bits value. Urgent is also 16 bits value. So total size of TCP header is 20 byte, or you can say 160 bits. Done. This is your TCP header. Is it clear to everyone? Total size of this header is 160 bits, or you can say 20 byte. In last class we had discussed this. The size of TCP is 20 byte and size of UDP is 8 bytes. Yes or no? Yes, Rohit?
Yes, sir.
So today, source port and destination port we had already discussed. We are going to start with sequence number. So sequence number is an 32 bits address. So range will be 0 to 2 to the power 32. Done. Okay. Let's understand how we are using sequencing. Sequence number. Okay. First of all, before starting the sequencing, tell me the protocol which are using TCP will perform three-way handshake before sending actual data. Yes or no?
Yes, sir.
So why? What is the purpose of three-way handshake? May I know what is the purpose of three-way handshake? In last class also we had discussed purpose of three
To make sure that whether the server is working properly or not before
Very good.
requesting for data.
This is first use of it. Yes, to check, or directly you can say to check that my server is alive or not, or that services are running on server or not. Right? If I am requesting for telnet access to a router and let's say telnet service is not running there, so there is no logic of sending telnet data to that router. Yes or no?
Yes, sir.
So first through three-way handshake we will check that service is running there or not. Okay, so what we can do, first purpose of three-way handshake can be port number, or we can say service port number is opened or not. This is the first use of three-way handshake. Yes, any other use? To check availability also we can say availability of destination machine. Done. Anything else? The main purpose of three-way handshake is sequence number initialization. Sequence number initialization. Actually, machines are going to initialize the sequence number. Initialize. Okay, and fourth use is negotiation of MSS. What is MSS?
Maximum segment size.
Yes. These
Uh,
four are the reason of three-way handshake. Purpose of three-way handshake. Yes, Rohit.
Maximum data segment can carry.
Maximum segment size. Yes. It is going to actually negotiate the maximum segment size. It will negotiate the MTU and lowest MTU will become what? MSS between source and destination. You know, here in TCP we can track the data, that which data is received by the receiver machine or not. We can keeping track of data. If any segment will lost, we can perform retransmission for that segment. Means we have track of data in TCP, in case of TCP. Okay, and through three-way handshake, first machines are going to check the server or the destination machine is alive or not with the help of three-way handshake. Or you can say three-way handshake is used to check that destination machine is giving acknowledgement or not, because in TCP acknowledgement is also required. So through three-way handshake we can check that I am getting acknowledgement from the destination machine or not. Getting my point? Getting my point, guys? Tell me frankly.
Yes, sir.
Yes. Okay. So in three-way handshake, sequencing will be little bit different from the actual data. Let's say I have two router 1 and router 2. Or you can consider PC as well. Let's say this is my R1, R2. Here I am using an IP address. Let's say I am using IP 10.1.1.1. Here I am using IP 10.1.1.2. Okay. Okay. If here on router number 1 directly I will type telnet and 10.1.1.2, and suppose telnet service is not enabled on router number 2. This is a question. Telnet service is not enabled on router number 2. Here I have typed telnet 10.1.1.2. Definitely router 1 will send one SYN message, yes or no?
Yes, sir.
SYN message. In the SYN message, sequence number will be
0.
yes, sequence number will be 0 and acknowledgement number will be also
0.
0. What router 2 will do? Router 2 will send acknowledgement or SYN plus ACK message. Actually, router 1 have not sent the actual information. Actual information is of telnet. Yes or no?
Yes, sir.
Right? So first it will build logical connection. So it is performing three-way handshake. It have sent the first SYN message. It have sent first SYN message. But on router number 2, telnet service is not enabled. In this SYN message, can anyone tell me what will be the source port number and what will be the destination port number? What will be source
Yes.
port number, guys?
Source port is you're going to be a random and destination port is going to be a telnet is 23.
Yes, source port will be the random port number and destination port will be 23. But 23 services is not enabled on R2. So what R2 will do? Yes, Nirav? Are you there? Yes, Nirav. What R2 will do here?
So can you repeat the question actually?
Question is on router number 2 telnet service is not enabled. I am trying to take telnet access from router number 1. Router number 1 trying to build the logical connection. It is trying to perform three-way handshake. So it have sent the SYN message. Now after
But
receiving the SYN message, what router 2 will do?
sir, it will discard because we have not enabled the telnet service.
Okay. At which layer
On
router 2 will discard it?
it will discard it at layer 4.
And do you think after discarding router 2 will generate any message to inform router 1?
That I am
Otherwise router
unsure.
1 will after retransmission timeout it will again send the SYN message.
Yes.
Again router 2 will discard.
Yes.
Again router 1 will send SYN message. Yes or no?
Yes. Yes. True.
So guys, this will not happen. Actually router 2 will definitely discard this SYN message and it will generate one reset message. Reset plus ACK. It will send one reset plus ACK message. What is the purpose of reset message? Reset means, brother, router 2 is telling to R1, brother, don't send any SYN message because this service is not enabled on me. Yes or no?
Yes, sir.
Okay. And suppose here telnet is enabled on router number 2. Then it will send what? SYN plus ACK. Then it will send SYN plus ACK. Yes or no? What will be the sequence number? Sequence
1.
number will be
Sequence
0.
1. Oh, sequence 0.
And acknowledgement number will be what?
1.
Acknowledgement number will be 1. And after that, router 1 will send one SYN message. Yes or no? And in this SYN message, sorry, ACK message, not SYN message, extremely sorry. ACK, acknowledgement. In this acknowledgement message, sequence number will be what?
1.
Sequence number will be 1. And acknowledgement number?
1.
Acknowledgement number will be also 1. Done. Now there is one TCP connection between R1 and R2. Yes or no? Now R1 is going to send the actual message of telnet. Yes or no?
Yes, sir.
Let's say it have sent the first actual message. Let me remove the TCP. Okay. Now router 1 have sent one actual telnet message. Here sequence number is, let's say, sequence number is 100. Acknowledgement number is, okay, here acknowledgement number is not required. Let's say sequence number is 100 and size of data is, let's say 200 byte. 200 byte. So R2 will give acknowledgement on what acknowledgement number? This is again your question, Nirav. Here acknowledgement number will be what? Actually telnet is an TCP based connection, right? TCP based services. So after sending the message, router 1 will receive acknowledgement. So router 1 have sent one message with sequence number 100 and size of data is 200 byte. What will be the acknowledgement number of the packet which router 2 will send to router 1? The acknowledgement packet.
300.
Acknowledgement number will be very good, 300. Yes or no? Is it clear, guys, everyone? So see the difference between sequence number and acknowledgement number while three-way handshake and while sending actual data. Done? And let's say window size between router 1 and router 2 is, okay, before discussing window size, let's say router 1 have sent one another telnet message to router 2. This time sequence number over here will be what? Here what will be the sequence number?
$301.
Not 301, only 300. Means router number 2 have received till 300. I am sending next message on sequence number 300. And size of data is again, let's say what? 200 byte. Again router 2 will give a acknowledgement on what acknowledgement number? 300 plus
500.
500. So router 2 will send acknowledgement on 500. Let me ask you some more question. I think you guys have still some confusion over here. Computer A, computer B. Computer A have sent one data. Sequence number is, let's say 1001 and the size of data is 200 byte. What will be the acknowledgement number over here? Acknowledgement
300.
number?
300.
Not 300.
1001.
Yes. 1001 plus 200.
1001 is the sequence number and size of data is 200 byte. So acknowledgement will be
1201.
1201. Let's say it have sent again the data and sequence number is, yes.
Sir, if data will be in bit, then we can directly.
Data will be in byte only. Data
Okay.
will be in byte only.
We have to convert it into the byte.
Byte. Sequence number and acknowledgement number always calculates in byte. Okay, not in bits. Done. Okay. Again PC1 have sent the data whose size is 200 byte and sequence number is 1201. So what will be the acknowledgement number this time?
1401.
1401. Again it have sent the data where sequence number is 1401 and the size of data is, let's say, 100 byte. What will be the acknowledgement?
1501.
1501. Very good. Is it clear to everyone how sequencing will work? Hello
Yes, sir.
guys, if anyone have doubt please let me know.
सर पहला
Suresh?
सीक्वेंस नंबर कैसे जनरेट होगा? रैंडम होगा?
वही तो पहला सीक्वेंस नंबर ही जनरेट करने के लिए थ्री वे हैंडशेक हुआ है. बताया तो आपको पर्पस में कि टू इनिशियलाइज द सीक्वेंस नंबर. क्या सीक्वेंस नंबर हम यूज करेंगे अभी समझ जाओगे आप. इसमें सबको क्लियर है ये चीजें? यस चंद्र
Sir,
प्रकाश.
only destination router will generate the acknowledgement.
Yes.
And why source router is not generating?
Because source is not receiving any data, na?
Okay, it is sending the data.
Yes. Acknowledgement is for whom?
Yeah, to receive.
For the
I have
sender
received your
machine,
data.
na?
Yes.
Yes. Sequence number track what is sent and acknowledgement number track what is received. Getting my point? Always keep in mind this. Okay. Yes, Mohan. Is it clear to you?
Sir, it is very similar to the post office scenario.
Yeah.
We have suppose we have to send a letter to anyone, we have to generate a sequence number and put an address on that. After receiving
Exactly.
the letter, the person is acknowledged, I have received your letter.
Exactly. Now I am going to, set the window size over here. As you know, what is the use of window size? What is window size? Yes. Who will explain the window size?
How many requests a server can handle?
Yes. Anything else? Guys, most of the people are not speaking, like Mohan, Suresh, Fam, Deepak. Why you guys are not speaking? Okay, leave.
Window size
See,
is
window size is,
used to control the flow of data.
or you can say it is used to reduce the number of acknowledgement. After
Okay.
every segment, if receiver machine or destination machine will send one acknowledgement, then communication process will be very slow. Yes or no? So that's
Yes,
why
sir.
we come up with window technique. Both machine, while three-way handshake, both machine will negotiate their buffer memory. On the basis of buffer memory, they will decide one window size, right? And after the window size, receiver machine will send the acknowledgement. After receive, the data equal to window size. Let's say I have one computer over here. Like this. Okay. And here window size is 500 bytes, right? So this machine A, machine 1, machine 2. Let's say machine 1 have sent one data with sequence number. Let's say sequence number is anything 1201, right? And size of data is 200 byte. So do you think that computer 2 will generate acknowledgement? No. It will wait for the next segment. Here sequence number will be what? Sequence number will be 1401. Yes. And size of data is again 200 byte. Again it will send one more segment. Sequence number will be what?
1601.
160.
601. And let's say size is
100, sir.
100. So this time computer 2 will generate what? Acknowledgement.
Acknowledgement.
And what will be the acknowledgement number?
1601, sir. No,
Huh?
1701.
1701. Very good. Last sequence number plus data length is known as acknowledgement number. While sending data, sequence number plus the data is acknowledgement. And while three-way handshake, sequence number plus 1 is acknowledgement. Yes or no?
Yes, sir.
Hope now it's guys clear. And if you will try to find the acknowledgement number and sequence number in Wireshark, so you will not get the exact answer, right answer, because there are relative acknowledgement number and sequence number. And I also observed many times there are wrong entry in Wireshark. So that's why I would not recommend you to check the sequence number and acknowledgement number in the Wireshark. But here I am going to just perform one practical, simple practical of, let's say, any application layer protocol telnet. Can I change MSS value on router? Do anyone know how to change MSS value?
Increase the MTU size, sir.
No, MTU is different thing.
Okay.
MTU is different thing, brother. So first of all, I am going to capture the link. First of all, let me show you the reset bit on message. How router 2 will send reset bit. First of all, let me configure the IP address. So let me do one thing. Config T interface F0/0 no set, and IP address is 10.1.1.1. Guys, after running this command 10.0.0.0.255.255.255.0, first thing router will do, once I will hit enter, what first thing router will do?
It will assign IP address.
No, it will check that this IP address is duplicate or
Ah,
not.
duplicacy.
Yes or no? Before
Yeah.
assigning, it will check the duplicacy. Through which message it is going to check duplicacy? Through GARP, Gracious ARP. See, I have entered over here and see the capturing. Are you able to see the Gracious ARP message?
Yes, sir.
Source is, wait, here, let me open it. Source is what? Source IP, same. Destination IP, same. Target IP and source IP both are 10.1.1.1. Who will generate reply to this message? The machine who is using this IP address, yes or no?
Yes, sir.
So no one is using this IP address, that means no one is going to generate the reply. Okay, so then if router will receive any reply, then it will give you the error. If router will not receive any reply, it will assign the IP address to their interface. Done.
So it means it's
At
going
layer
to
2,
broadcast. So
yes,
every time,
broadcast.
whenever you.
At layer 2 it is going to broadcast, and at layer 3 it is unicast. Okay. Okay, this is not my concern now. I have configured the IP address over here. Now I am going to configure IP on router number 2. Config T interface F0/0, say no set, and here IP address is 10.1.1.2, 255.255.255.0. Done. Line VTY 04, and let's say transport input none. I have disabled the telnet over here. Okay, and here is my capturing. I am going to send the telnet message. Telnet 10.1.1.2. It is trying. See the SYN message. Who have sent this SYN message? 10.1.1.1 to 12.1.1.1. And 10.1.1.2 is sending what? Reset plus acknowledgement. Yes or no? Hello.
Yes.
Yes,
Sir.
sir.
Yes.
Here flag only SYN bit is on, and as I told you that in new TCP you can see only 3 bits are reserved and 9 bits are in use. And router 2 is sending reset bit, acknowledgement and reset. It giving acknowledgement on acknowledgement number what? Acknowledgement number 1, yes or no? Of sequence number. If this router 2 will not send the reset message, then router 1 after some time, after retransmission timeout, it will send again the SYN message. But now router 1 is not going to resend the SYN message. Here you can see connection refused by remote host. Now I am going to enable telnet over here. Line VTY 04 transport input telnet, and say no, login, password is not required. Done. Okay, again I am going to send telnet traffic, and this time you can see I have access of router 2 and everything is working fine. Here also you can see SYN message. 10.1 have sent SYN message to 10.2 first. Wait, let me stop it. It have sent one SYN message and sequence number is, in the SYN message sequence number is 0. Sequence number is 0. Next sequence number is 1. Source port number is random port number. Destination port is well known port number. Port number of 23. Yes. SYN bit is on.
सर ये
After
फ्लैग्स होते
that,
हैं सिन प्लस एक जो जाता है फ्लैग है, फ्लैग भी टोन होती है।
yes, flag on, flag bit on होते हैं बस, और बाकी TCP के हेडर है।
तो मतलब हर बार हेडर जाता है और ये इंफॉर्मेशन एक्टिव हो जाती है, जैसे
हेडर जाते हैं और उसमें एक्नॉलेजमेंट बिट ऑन हो गया, रीसेट बिट ऑन हो गया, पुश बिट ऑन हो गया, फिन बिट ऑन हो गया, ऐसे।
और सर ये क्यों कहते हैं कि हेडर का जो साइज है 20 to 60 बाइट तक जा सकता है?
क्योंकि उसमें जो ऑप्शन है ना, ऑप्शन फील्ड को हम लोग यूज कर सकते हैं, वो आप बाद में समझ जाओगे, अभी रुक जाओ।
ओके सर, ओके सर।
अभी यहाँ पे थोड़ा सा फोकस करिए। फर्स्ट ऑफ ऑल, फर्स्ट मैसेज 10.1 have sent to 10.2 SYN message where sequence number is 0, right? And MSS is 1460
bytes.
1460 bytes. Okay. After that, router 2 have sent SYN plus ACK. SYN plus ACK. Both bits are on, and here sequence number and acknowledgement number. Sequence number is 0, but acknowledgement number is what? 1, because sequence number plus 1. Done. In the same way, when router 1 will send the acknowledgement, in this acknowledgement also acknowledgement number will be what? 1. Okay. Okay, now see the actual data. This is actual data of Telnet, who have sent 10.1.1.1 to 10.1.1.2. Sequence number is and size of data is header length is this one.
Showing 12 bytes sir, TCP load.
Where?
Sir, go down sir, a bit sir. यहाँ sir, ये रहा TCP payload sir, at last line sir.
12 byte. 12 byte, and the sequence number is 1. So it should give acknowledgement on what acknowledgement number?
13 sir.
13. And next sequence number is what?
13.
13. So see. Acknowledgement is what? Acknowledgement number is 13. So while sending the actual data, acknowledgement number, you know, use of sequence number and acknowledgement number is different from the three-way handshake, and these two are very important for interview. Okay. When router 1 will send the next telnet message, sequence number will be what? 13. See, the next telnet message, sequence number is 13, and like this you can calculate the acknowledgement and you can verify by yourself. Okay, like this you can see there are lots of data of telnet. Okay, Now, if I will configure, guys, can I ask you one question here?
Yes, sir.
Nirav?
Yes, sir.
Okay, if I will apply one access control list over here. See, telnet service is enabled on router number 2, but I will apply one access control list. Access control list, so that whenever router 1 will try to access telnet, right, it will drop the traffic. So while three-way handshake, what router 2 will do? Router 2 will receive the traffic SYN message. And what
Yes.
router 2 will do? If I will
It will
configure
go
the
through
access.
it will go through the access list and very first packet when it matches, then it will again set that reset connection.
It will send reset connection.
No. It will not reset, but it will deny the packet because it will match the ACL.
Okay.
Sir, I think packet is dropped by ACL, not even reach the route. At interface level, it is going to drop.
Okay, if I will block only telnet services on this router, but telnet service is enabled, but telnet service is blocked.
So for particular that network, it's going to drop the traffic.
Okay, how to check that TCP connection is there or not between router 1 and router 2? So, TCP
TCP brief.
brief. Yes. Now, by checking this value, can anyone tell me who have initiated this connection?
Foreign address 10111
Yes, 10111.
because
And
it
here
is
you can
random.
see this one is using also random port number.
Yes.
Okay. Exit. And let me try something over here. Access list.
Sir, extended access list.
Standard, let me block the IP first.
Okay.
Deny host 10.1.1.1. Exit interface F0/0 IP access group 10 direction in. You know, this time what will happen? Again, I am going to capture the link. This time router 2 will send one ICMP traffic. See. Stop capturing. I think this time router should send type 3 ICMP traffic. Type 3 ICMP traffic is destination unreachable. I have apply access list. Let me check the capturing. Okay. Again, from router number 1, I am going to say telnet. This one. Okay. Yes. SYN message. After SYN message, you can see router 1 have sent the SYN message 10.1, 10.2. This is a SYN message. Source port is random port number. Destination is 23. Sequence number is 10. But router 2 have sent one ICMP traffic. Type is 3. 3 means destination unreachable. Don't know why people are joining now. When class is about to finish, then people are joining. Okay. Okay, so where I was? Yes. Type, it will send, router 2 will send one ICMP traffic. And same thing happened in case of ping as well. If you will ping from router number 1 to router number 2, router number 2 will send one ICMP type 3 message. Because here you can see the destination communication administratively filtered. Service is available, yes or no? This router is 10.1.1.2. You can
Yes.
take telnet access, but the service is filtered. IP is filtered by the administrator. Okay, and by using this command, router 2 will tell to router 1 so that router 1 will not send SYN message again. Done. Debug IP TCP packets and debug telnet. Okay, let me remove the access control list. Interface F0/0, no IP, access group 10 direction in, no IP, access list 10, standard 10. Okay guys, so hope now acknowledgement, sequencing and acknowledgement is clear to everyone. And in UDP header, like in TCP header, there are lots of information, but in UDP header, there are very less information. I think there should be UDP header as well. UDP header, yes. You can see in UDP header, there is source port, destination port, header length, checksum, and this is your actual data. That's it. That's it. In TCP header, you can see these are the information. Header length is, here you can read the each field. Sequence number is used by the TCP that put the data back in the correct order or retransmit missing data during the process called sequencing. Acknowledgement, header length, it is the size of TCP header which indicate where the data began. By default it is 20 byte. Reserve field is always 0, right? This is not for, this is not in used now, this is for future used. In old TCP header 6 bits was reserved, but in the latest TCP header now only 3 bits are reserved. Maybe in future we will use all bits. After that flag, so as you already know that it is used for control function, which is, it is a control function which is used to set up and terminate the session. There are 8 flag in TCP header window. We had already discussed the window size. Yes or no?
Yes, sir.
After that, the checksum field is used to find the error in TCP header. Can anyone tell me how checksum works? This is a part of, by the way, security, but basic knowledge do you have, guys? What devices is going to do with checksum?
Sir, maybe there is some kind of algorithm who generate a random number, and
Yeah,
at the other end, it's going to again generate the same number. If the both the number are same, then uh, the packet is
very good. Exactly. Exactly. Both side sender and receiver are actually going to run the algorithm, and by running the algorithm, they are going to calculate one hash value. If hash value will match, that means there is no any error. After that, we have IP header, but we are not going to start IP header now. First of all, at transport layer, we have some more concept. I have one router over here. And let's say I have one server over here, server, and we have one computer. This computer want to send some data to server, and that is TCP based data. Let's say here I have, this is my router 1, R1, R2, R3, this is PC, and this is server. Okay, suppose MTU, I am talking about MTU, not MSS. MTU stand for,
Maximum transmission unit.
yes, maximum transfer unit. Let's say
Transfer
MTU of this interface is 1500 byte. MTU of this interface is, let's say, 100 byte only. MTU of this interface is 600 byte. MTU of this interface is, let's say, 700 byte. MTU of this interface is, let's say, only 200 byte. Okay, now can you tell me, PC can send traffic to server whose size can be up to what?
100, sir. Average size.
100. No, wrong. Why? Suppose if PC is sending one data whose size is more than 100 byte, let's say 150 byte, it will forward to router number 1. Router 1 can forward it because their MTU is 1500 byte, so it can forward it to router 2. Router 2 can also forward it because its MTU is 600 byte. It can forward it to router number 3, and router 3 can also forward it to server because its MTU is 200 byte.
So it's divide according to the MTU size.
Yes.
Sir,
What
it
is
will
the-
it will
Yes.
set fragment bit for discussing this lower MTU.
What is the
LSM.
lowest MTU value between PC1 and server?
100.
100, sir.
100. This one. Can this router receive a data on this interface whose size is 200 byte? Tell me.
No, sir.
No, sir.
No.
Yes.
It will receive in parts, sir. But
No,
not,
no, it can receive 200 byte data. This is only transfer. It cannot transmit.
Okay. Transmit.
MTU stand for maximum transfer unit.
Okay,
Getting
so
my point?
okay, yeah. Okay.
It can receive 200 byte data, but it cannot transfer 200 byte data from this interface.
Yes, I
Done.
got it. Got it.
But when server will generate reply, that time this machine cannot transfer more than 100 byte data from here. Yes or no?
yes, sir.
Yes.
So minimum MTU between PC to servers is 100. Definitely. Right? So while three-way handshake, PC will have information about the MSS, the maximum segment size. Yes or no?
Yes, sir.
So one size of one segment should be 100 only. Yes or no?
Yes, sir.
So if a PC is generating a data whose size is 100, then again problem is it will add 20 byte extra information at transport layer. Yes or no?
Yes,
So
sir.
total size of data is
120.
120.
120. No. That means data size should be what? 80.
80.
Still problem, because like transport header, like transport layer, we have 20 byte extra information. At layer 3 also we have
Sir,
20 byte extra information. So actual size of data should be what? 60 byte. Now 60 bytes plus 20 byte transport header plus 20 byte network layer header. We always subtract 40 byte for header.
sir, what about
And
data link layer, sir?
no, data link layer, data link layer will add header on the link. Actually, when router will receive traffic over here, first it will remove data link header on the link. And when it will forward it from here, again it will add data link header over here. That is layer 2 MTU, brother.
अच्छा सर, ये हॉप टू हॉप तक ही रहते हैं और वो केवल लिंक पे ही लगा के भेज देता है, वहां आगे जाके रिमूव हो जाता है.
Yes. That is layer 2 MTU. We are talking about the layer 3 MTU now. This is layer 3 MTU.
Okay.
Okay. So data link layer size, we will not consider data link layer size in MSS. Done. By default, MTU of Cisco devices is 1500 byte. So you tell me what should be the size of one segment?
1460.
1460, because here we will add 20 byte for transport
TCP
header and 20
and
byte
IP
for
for header.
exactly. Okay, so size of one segment, and this is the reason why while three-way handshake machines are negotiating maximum segment size. Actually, machines are negotiating the MTU, maximum transfer unit. According to that, they select the MSS. Okay. So suppose I have one computer A, computer B, here one, two. From here, if I am generating one HTTP request, S request, so it will generate an application layer. Application layer will hand over it to directly transport layer. But because nowadays we are not using OSI model, we are using what? TCP IP model. In TCP IP model, we have how many layers?
5.
5
5
layers.
layers only. Application, then
Transport.
Application
transport layer directly. So here transport layer will do what? Transport layer will add one transport header with HTTP and plus transport layer header. Transport layer header can be TCP or UDP, yes or no?
Yes.
Yes, sir.
And after that, what we called it? We called it segment. We called it segment. Segment means actual data plus
Your
TCP
header.
header.
TCP header or UDP header. Yes or no?
Sir, UDP, when we add the UDP header, it's
In
known
case
as
of like
datagram. Instead
user, yes. In case of DNS,
because some of the website it mentioned if you are using at transport layer UDP, then it is going to known as, instead of segment, it's going to known as datagram.
no. That is also segment. Segment means actual payload. Payload means actual information plus header. It can be any header at transport layer. Okay. It can be any layer at transport layer. It can be TCP, it can be UDP, or it can be any other layer, any other header. Done. After that, it will hand over, transport layer will hand over the segment to
Internetwork.
main to
Network layer. Internet
network layer, and network layer will add what?
Packet.
IPv4
Network
header.
layer Yes, network layer header, it can be IPv4 or it can be
IPv6
IPv6. After that, what we called it?
frame.
Packet
Yes,
frame
Sorry,
we called it
packet.
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 Packet. Packet means segment plus network layer header. And for network layer, this segment is actual information, payload. Yes or no?
Yes, sir.
Right. After that, network layer will hand over this packet to data link layer. Data link layer will add one header with packet.
And trailer, header and trailer. That's why it is known as frame.
Yes. Or directly here I am going to say data link header. And what we call it? We call it then frame. Frame. Frame means again payload plus data link layer header. And after that, data link header will hand over it to physical layer.
Bits.
Physical layer will convert it into bits. After that, into maybe signal, and it will,
Electrical or light signal.
yes, and then it will transmit to PC2. PC2 will receive data at physical layer. Definitely yes, at physical layer. After that, physical layer will check what? Physical layer will convert bits again into frame, and it will hand over the frame to
Network layer.
not network layer,
It
to
will
data link layer.
Oh, sorry, data link layer.
And data link layer is going to open what? Data link header. Data link header. In the data link header, what are the information, guys? Source MAC maybe, destination MAC maybe. If we are using Ethernet link, then definitely there will be source MAC, destination MAC.
destination.
If
Yes.
we are using the serial link, there will be HDLC header. Okay, let's say we are using the Ethernet link, so there will be destination MAC. PC, first of all, PC is going to check the destination MAC address in data link header. If destination MAC address will be the MAC address of PC2, then only PC2 is going to check any other information. If destination MAC is not the MAC address of PC2, then it will discard it at layer 2. Always keep in mind, only in two cases PC will receive this data. One, if destination MAC address is the MAC address of PC2. Second, destination MAC address is MAC broadcast. Yes or no? Yes or no?
Yes, sir.
So destination is, let's say, MAC address of PC2. Then can anyone tell me what information layer 2 is going to check?
So IP.
No. How data link layer will came to know about the IP, or data link layer cannot check the IP? It is going to check the type field. It is going to check type field. In the type field, there will be information about the upper layer protocol. Upper layer protocol is IP. It will remove Ethernet header from here. It will remove the Ethernet header and it will hand over the actual packet to upper layer. That is IP protocol. IP protocol will check directly the destination IP address. If destination IP address is the IP address of this machine or broadcast, then only it will accept it. If destination IP is IP address of PC2, then it is going to check what? Protocol field. In protocol field, there will be information about upper layer protocol. So can anyone tell me what is the protocol number of TCP?
6.
6. So in protocol field, value will be 6. It will hand over traffic to TCP protocol directly at transport layer. Actually, it will open the packet, and it will remove the IP header. It will pick the segment and it will hand over the segment to transport TCP protocol at transport layer. And at transport layer, TCP protocol will check directly destination. Destination port is 443. It will hand over directly actual traffic to HTTP. Getting my point, guys? This will be the packet flow. Just we had I have give you overview of packet flow between two devices. This is how transport layer will work. Transport layer will check the destination. If destination port is 443, it will check the 443 service is enabled on me or not. If this service is enabled, I will hand over it to HTTP protocol. If this service is not enabled, I will discard it. If destination port is 23, I will check telnet is enabled or not. If telnet is enabled, I will hand over actual traffic to telnet. Otherwise, I will drop it. Done. If destination port is 67, I will check DHCP services is enabled on me or not. If DHCP services is enabled, I will remove the transport layer header and I will hand over the actual information to DHCP. Getting my point, guys?
Yes, sir.
So till now, we had discussed transport header.
सर जो डेटा है वो ट्रांसपोर्ट लेयर तक जाएगा, तभी उसके बाद ही चेक करेगा ना कि ये सर्विस रन हो रही है कि नहीं हो रही.
यस, एट ट्रांसपोर्ट लेयर
हाँ.
सर्विसेज. अगर आप बोलो ना कि सर्विसेज कौन से लेयर पे आइडेंटिफाई होगा, तो ट्रांसपोर्ट लेयर पे. होस्ट किस लेयर पे आइडेंटिफाई होगा, तो लेयर 3 पे. ऐसे. एंड
और आपने सर वो लेयर 2 पे क्या बताया था कि वो पहले चेक करेगा कि उसके बाद ही नेटवर्क लेवल
वो पैकेट फ्लो में आ जाएगा. अभी
ओके,
पैकेट
ओके,
फ्लो हम
ओके
लोग
सर.
डिस्कस करेंगे
ओके
ना. नाउ सी, from application layer to lower layer, we are adding extra information with actual data, and adding extra information with actual data is encapsulation. Encapsulation means adding extra information with actual data, and while receiving we have removed the extra information from actual data, that is decapsulation. So encapsulation and decapsulation is also important term in networking. Okay, just let me give you one more time overview. Data link layer, physical layer. No, this here is PDU at different layer. So at application layer we call data to data, right? Physical presentation and session also. But at layer 4 we call data to segment. At layer 3 we call data to packet. At layer 2 we call data to frame. At layer 1 we call data to bits. Encapsulation, decapsulation means like, see, I have computer 1 over here, and let's say this is my server, HTTP server. Here I have typed www.google.com. This is my google.com server. What this machine will do, this machine will generate one HTTP request at application layer. After that it will hand over to transport layer. Transport layer will add what? Transport header. Inside the transport header there will be source port number, destination port number. Source port number will be random port number and destination will be 443, well known. After that transport layer will hand over it to IP protocol. IP protocol will add IP header. Let's say here IP address is 10.1, here IP address is 10.2. So source IP address will be 10.1.1.1, destination IP will be 10.1.1.2, and there will be one protocol field. In protocol field there will be value of upper layer protocol, that is TCP. TCP protocol number 6. After that it will hand over to layer 2. Layer 2 will add what? Source MAC. Let's say MAC address of this machine is A, MAC address of this machine is B. Source MAC A, destination MAC B. if this machine don't know the destination MAC, definitely it will generate ARP. We will discuss that later. Destination MAC B, and there will be one type field. In the type field there will be information about IPv4, because who have hand over it to layer 2 IP protocol. So IPv4 type code is what? 0x. 0x. Can anyone tell me the type code of IPv4? Hello?
0x8100, I guess.
0x0800. This is the type code of IPv4. After that it will hand over to physical layer, and physical layer will convert it into bits, and then it will hand over to forward it from this link. Okay, here at physical layer it will receive bits, then it will receive frame at layer 2. In the frame it will check the destination MAC. Destination MAC is B. Okay, it will check this field and it will remove this header, like that. So see, here we are actually adding extra information at each layer. So this is encapsulation, and here on receiving machine, first we will remove this header, then we will remove this header at layer 3, then we will remove this header at layer 4, and after that we will pick actual information and we will hand over it to the HTTP protocol, actual protocol at the server. So here we will remove all header, all extra information. So here we will perform decapsulation. We will discuss these things while discussing packet flow also. Don't worry guys if anyone have confusion. Okay. So this is nothing but encapsulation and decapsulation. Now in TCP IP you can see we have only 5 layers: application, transport, internet, data link layer, and physical layer. This is TCP header, just we had discussed. This is UDP header, and this one is IP header. Before discussing the IP header, we have some network layer protocol. After discussing IP header, I will discuss the packet flow between two computers. Right, so this will be our next topic, that is IP header. Okay, in IP header we have lots of things, right, and it is very important as well. IP header, we already discussed IPv4 addressing, subnet mask, and subnetting. Yes or no? MAC addressing. So in OSI Moodle we have only one topic left, that is IP header. Yes or no guys?
Sir, just one query.
Yeah.
Like as you just told us about this TCP header that is around 20 bytes, correct?
Yes.
And in IPv4 that is also 20 bytes. So IPv4 header has got that fragmentation bit, correct?
Yes.
But then how TCP will come into existence for correct
For
sequence?
UDP, they don't have any foundation. The UDP can send any size of data. Yes or no?
Yes, that is okay. But for TCP connection, say for
Yes.
example, in
For TCP will send calculated data. TCP will not send the data which router need to fragment. Getting my point, Nirav?
but actually yesterday I was just watching one video regarding this fragmentation, sir. So in that they connected this R1 R2 same topology that you had,
Okay.
and from router 1 to router 2 what he did is that he set ping command, and then the default MTU is 1500. So he set the that particular size to be 2000.
Okay.
So yeah, and then he captured in packet capture, and then he showed that see that fragmentation bit is set. So that particular part, it will fall under TCP header or specifically under IPv4 header? Because in IPv4 header only it is available, sir.
That will be come under IPv4, by the way. But you know, whenever TCP based service, whenever any system send TCP based service, TCP based data, TCP based service data,
Okay.
so that service need to perform three-way handshake, and while three-way handshake, it will calculate the maximum segment size.
Yes.
So we don't, router don't need to perform fragmentation for the traffic which is generated by the TCP. After the three-way handshake, let's say if you have changed the MSS size by running this command, then only router need to perform fragmentation. We can set the minimum MSS value is can be 500 and maximum can be 1460 byte. Okay, Nirav.
Okay, sir.
Anything else, guys? Any doubt? क्वेश्चन बहुत कम आते हैं आप लोगों के पास, ये बात तो
Sir,
है।
I'll